You may not like Toyota, but they have a battery technology that could have the entire industry shaking in its boots. Making solid-state batteries has never been easy, but Toyota has finally brought this technology into production and is using it for electric vehicles with a range of up to 1,000 kilometers. But that's not even the biggest surprise about Toyota's solid-state batteries. What you're about to hear is going to blow your mind. For years, the entire EV industry has been stuck trying to answer three big questions. How do we make electric cars go farther? How do we make them charge faster? And how do we reduce battery weight without pushing the price of the car into ridiculous territory? Toyota believes solid-state batteries could answer all three questions at once. Imagine an electric car leaving Los Angeles in the morning, driving hundreds of miles without barely having to think about finding a charging station. And then, when you finally do need to charge, it could take only around 10 minutes to go from 10% to 80%. Not 30 minutes, not an hour. Just enough time to use the bathroom, grab a cup of coffee, and get right back in the car. The first generation of solid-state batteries Toyota is targeting is claimed to deliver around 1,000 kilometers of range under the WLTP standard, or roughly 621 miles. These batteries are expected to have an energy density of around 450 to 500 watt-hours per kilogram, and some reports suggest they could last more than 15 years while retaining over 90% of their capacity after 2,000 charging cycles. And Toyota isn't stopping there. The next generation of solid-state batteries is reportedly being developed with a target range of around 745 miles, or nearly 1,200 kilometers. So what does all of this actually mean? An electric vehicle could travel much farther than many gas-powered cars on a single charge, while fast charging times are getting closer and closer to the time it takes to fill up a gas tank. If the two biggest advantages ICE cars still have, range and refueling speed, start to disappear, what reason will customers have left to turn down an EV? But Toyota isn't planning to start with an ordinary electric Corolla. The technology is reportedly expected to debut first in the next-generation Lexus LFA, an all-electric supercar that recently made a near-silent dynamic debut at the Goodwood Festival of Speed. So why is Toyota choosing solid-state batteries for this car? Honestly, the reasoning is pretty simple. Solid-state batteries make a lot more sense in a supercar than they do in a mainstream vehicle. Conventional lithium-ion batteries need a massive battery pack to deliver long range, but the bigger the battery pack gets, the heavier the car becomes. And the heavier the car, the more energy it needs to accelerate, brake, and change direction. That's the paradox facing modern electric supercars. Many high-performance EVs today have massive amounts of power, but they also weigh as much as a large SUV. The motors respond instantly, the power output is enormous, and the acceleration can be brutal, but hundreds of extra kilograms of batteries make it harder for the car to deliver the agility and responsiveness drivers actually want. A car can go from 0 to 60 miles per hour in just a few seconds, but that doesn't automatically make it exciting when you hit the corners. Solid-state batteries could change that equation because they can pack more energy into a smaller, lighter package. As we mentioned earlier, the energy density of these batteries could potentially reach 500 watt-hours per kilogram. Normally, when people hear about solid-state batteries, they immediately think about longer range. But for the Lexus LFA, the more important advantage could actually be lower weight. A smaller, lighter battery pack that still delivers a respectable range could help the car accelerate faster, brake harder, change direction more effortlessly, and put less wear on the tires. Instead of building a more than 2-ton electric car just to brag about a 1,000-kilometer range, Lexus could use this technology to create the lightweight electric supercar the market is still missing. Lexus has also made it clear that it doesn't want to turn the car into some kind of fake internal combustion experience. While some automakers are adding artificial engine sounds, simulated gearboxes, and programmed shift sensations, the LFA program's leadership believes buyers could see an EV as artificial when it tries too hard to imitate a gas-powered car. Instead, Lexus wants to eliminate unwanted noise, control vibrations, and bring out the sounds that actually come from the electric motors, drivetrain, and movement of the car itself. It's a risky decision. Fake engine sounds and simulated gear shifts may not make the car any faster, but they create emotion. Even people who know those sounds are generated by software can still enjoy them. Toyota is taking the opposite approach. The company wants to convince customers that an EV doesn't need to pretend to be a gas-powered car to be exciting. Electric motors already deliver the instant, linear response that internal combustion engines struggle to replicate. The challenge for Lexus is turning that precision, silence, and instant response into an entirely new kind of driving emotion. But before we call this a victory, there's one uncomfortable fact we can't ignore. Toyota has promised solid-state batteries too many times before. Back in 2014, Toyota researchers said high-performance solid-state batteries could be ready for the market by 2020. Then, in 2017, the company said it was developing manufacturing technology to commercialize the technology in the early 2020. Toyota later demonstrated a prototype, but 2020 came and went without a single solid-state battery-powered car showing up in a showroom. The timelines kept moving. First it was 2020, then 2023, then 2025, 2026, and eventually around 2027 or 2028. At one point, Toyota even said the first vehicles to use this technology would be hybrids rather than fully electric cars, but that plan never turned into a commercial product as expected either. So what exactly has been holding Toyota back? The answer isn't that solid-state batteries don't work. They absolutely can store energy and deliver power to a vehicle. The real problem is that they haven't consistently lasted long enough, performed reliably enough, or become cheap enough to manufacture at scale. In today's lithium-ion batteries, the liquid electrolyte can flow around the electrode materials and fill tiny gaps between them. But in a solid-state battery, the solid particles have to stay in direct contact with one another. Every time the battery charges and discharges, those materials expand and contract. Tiny gaps can form, parts of the surfaces lose contact, resistance increases, and the battery starts to degrade. That's why a cell can deliver incredible numbers in a laboratory and still fail after hundreds or thousands of real-world cycles. An electric vehicle doesn't just need to deliver 1,000 kilometers of range on day one. It has to keep delivering a reasonable range after years of fast charging, hard acceleration, freezing winters, scorching summers, and tens of thousands of kilometers of vibration on the road. And while Toyota is trying to prove that this time it's actually ready, two other rivals have started putting pressure on the company from two completely different directions. Now look at China, which has remained at the forefront of battery innovation, and BYD is taking a completely different approach to solid-state batteries. Toyota is grabbing headlines with claims of 1,000 kilometers of range and charging times of around 10 minutes, while BYD is focusing on the less flashy engineering problem that could ultimately decide the entire race: how to keep a battery from cracking, losing contact between its materials, and degrading after thousands of charging cycles. Over the past 2 years, BYD has invested heavily in sulfide-based solid-state battery technology, targeting an energy density of around 400 watt-hours per kilogram in its first generation, with plans to push that figure toward 500 watt-hours per kilogram in the near future. BYD says EVs equipped with this technology could deliver an impressive 500 to nearly 600 miles of range on a single full charge under the NEDC cycle. Even more importantly, the technology is designed to support ultra-fast charging, with tests reportedly showing the ability to add as much as 400 miles of range in roughly 12 minutes. More recently, BYD also filed a new patent for a composite solid electrolyte membrane, the layer positioned between the anode and cathode. The structure combines inorganic electrolyte particles of different sizes with a lithium salt-containing polymer fiber network. These polymer fibers partially wrap around the surfaces of the inorganic particles, helping improve both ion conductivity and the mechanical strength of the electrolyte layer. This matters because solid-state batteries don't fail because they can't store energy. The real problem is what happens to the materials inside as they continuously expand and contract during charging and discharging. After hundreds of cycles, tiny cracks can start to form. The solid surfaces can begin separating from each other. Resistance increases and capacity starts to drop. A battery that can deliver 1,000 kilometers of range on day one doesn't mean much if it loses a significant portion of that performance just a few years later. BYD acknowledges that maintaining stability at solid-solid interfaces and preventing lithium dendrites are still two major challenges. Dendrites are tiny lithium structures that can grow through the electrolyte, potentially causing short circuits or reducing battery life. The fact that BYD is openly addressing these problems suggests the company isn't just promoting ideal numbers. It's directly tackling the weaknesses that have delayed solid-state batteries for years. BYD is targeting a pilot-scale rollout in 2027. Around the same time, several other Chinese battery makers are expected to begin putting solid-state cells into vehicles. Despite the promise, BYD is still taking a cautious approach. Some senior executives have said that the second-generation blade battery, a low-cost LFP technology, will continue to have the advantage in terms of cost and overall economics in the short term, while early solid-state batteries will be more expensive and face major challenges when it comes to scaling up production. Even so, given BYD's leading position in the battery industry, solid-state technology is seen as a key piece of the company's strategy to maintain its dominance in the global EV market and compete directly with giants like CATL, Toyota, and Samsung SDI. But just as BYD is trying to solve the problem at the materials level, Factorial is coming at it from an even more direct angle, putting solid-state batteries into real cars and forcing the technology to prove itself on the road. Factorial is a US-based battery company backed by Stellantis, Mercedes-Benz, Hyundai, and Kia. Instead of simply announcing a patent or showing off a number from a laboratory test, the company has partnered with Stellantis to put its solid-state battery cells into the Dodge Charger Daytona, a big, heavy electric muscle car that was never designed to be an efficiency champion. And that's exactly why this test is so interesting. If a solid-state battery can deliver impressive range in a heavy Dodge Charger, the same technology could potentially be even more effective in a smaller sedan or a lighter crossover. Factorial's cells are reportedly capable of around 375 watt-hours per kilogram, roughly 35 to 40% higher than many of the NMC cells currently used in EVs. They can reportedly charge from 15% to 90% in about 18 minutes and operate across a temperature range of roughly -30 to 45 degrees Celsius. But there's one important detail to clarify. Stellantis has not disclosed the exact capacity of the Dodge's battery pack, nor has it confirmed a range of more than 1,000 kilometers. That figure is mainly inferred from the energy density of Factorial's cells and previous test results involving the Mercedes-Benz EQS. The Mercedes test vehicle reportedly traveled around 750 miles or more than 1,200 kilometers, while still having an estimated 85 miles of range left. If those numbers accurately reflect the battery pack's capabilities, its total potential range could exceed 1,300 kilometers. That makes the idea of a Dodge Charger achieving more than 1,000 kilometers of range sound a lot less far-fetched. But range isn't the most important thing Stellantis is testing. The real question is how many charge and discharge cycles the battery can survive under real-world conditions. Solid-state batteries don't fail because they can't work. They fail because many designs degrade too quickly. In the lab, a cell can deliver incredible numbers, but out on the road it has to deal with constant vibration, temperature changes, hard acceleration, repeated fast charging, and thousands of charge cycles. If these cells can maintain their capacity after thousands of cycles and can be manufactured at a reasonable cost, Factorial could become the company that brings solid-state batteries to market before Toyota can turn its 1,000-kilometer promise into a commercial product. And if that happens, Toyota may not be able to afford another delay.